In this video, we're going to talk about another way to solve logarithmic equations, and that's using inverses. Alright, so far we learned to solve exponentials and logarithms using the exact same method called this one-to-one property. So if we have two exponentials equal to each other, we kind of ignore them, and we just set those exponents equal. If we get a single log equal to each other, we kind of ignore them, and we just set the insides equal. So that works whenever you can rewrite these exponentials or logs with the same base. What happens when you can't write both sides of the equation using the same base? All right, that's what we need to figure out now. All right, so what about this one? 3 to the x equals 6. We had equations like 3 to the x equals 9. 9 I can rewrite as 3 squared, then x has to be 2, and that was fine. But in this case, 6, I can't rewrite it as a nice power of 3. It's 3 times 2, but that doesn't help because that's not an exponent. So I can't really use this one-to-one method because I can't rewrite this as base 3. So I need another way, and the other way is going all the way back to when we first started talking about logs and exponentials, that if we had an exponential that looks like this, we can always go back and forward to my log that looks like that. All right, I can go back and forth with the logs, the bases are the same, and the input and output switch places. So I can do that same thing here. I can rewrite this as log base 3. This output becomes the input. This input becomes the output. Now I have x all by itself. All right, for this skill check and the test and everything, you leave your answer like this. If you really want to, you can put this in a calculator. I'm not going to do that because I'm fine with this as an answer. All right, but log base 3 of 6 is your x value. All right, so since exponentials and logarithms are inverses, we can always switch between them as long as we put everything in the right place. All right, so remember, just this input and output is the big thing that's switching. All right, so what about 2 cubed times 2 to the x equals 9? All right, in order to use this definition, I have to have a single exponent equals a number. We just have a number over here, but we don't have a single exponential over here. We need to combine them, and we do that by adding the exponents. And now I have kind of that same situation we had in the first example. I can rewrite this as log base 2 of 9 equals 3 plus x. And now I need to get this x by itself, so I just need to get rid of the 3 and subtract 3. Right. This is all one number, so I can't like subtract the 3 into this parentheses because this 9 is kind of wrapped up with the log, so I just have to leave it like this. And again, I would prefer you leave it like this, but if you really want to find the decimal for this, you can put it in your calculator. But this is the exact answer versus the decimal would have some rounding. But just like we were kind of combining stuff with exponentials before, combine them into a single exponential. We can't rewrite 9 as the power of 2, so we have to rely on logarithms, and we get an answer that looks like this. All right, so this is one for you to try on your own. All right, what is the solution for x for this example? I'll show the answer in 3, 2, 1. All right, this one, when it's just a single x, it's just a case of basically rewriting an exponential as a log, and you get x by itself. All right, so we can do the same thing with logarithms. All right, just quickly remember our logarithm rules we've been using. If you add two logs together, you can smush them together and multiply the insides. If you're subtracting two logs, you smush them together and divide the insides. And if you have a number in front of a log, you can always bring that in as an exponent. And also these rules work the other direction as well, but generally when we're solving an equation, we're doing these left to right. All right, so log base 2 of x equals 3. When we were doing logs before, we wanted like log base 2 of x equals log base 2 of 3. Now these are both logs, we can cancel them out. But in this case, there's no log on the right-hand side. So we can't use this one-to-one method, but we can always go backwards between logs and exponentials. So I can take this base 2, I raise it to this exponent 3, and I get the inside x. And then 2 cubed, I know, is just 2 times 2 times 2 is 8, and 8 equals x. All right, one final thing we always have to do with log equations that we don't have to do with exponential equations is check for extraneous roots. But I can put 8 into a log because it's positive, so that is the answer. All right, this one's similar, but we have multiple logs on one side. But we can always get rid of multiple logs by just combining them using our log rules. There's a plus sign, so I multiply. There's not a log on both sides, so I have to use my inverses. So we get 3 cubed equals 4x. 3 cubed is 27. Divide by 4. Get my final answer. Right, again, double check it's a log equation. Does 27 over 4 work? 27 over 4 is 7.75 or something, so it's fine to plug in because it's positive. All right. All right, another one, very similar, except for there's a minus sign. But minus sign, the only thing that changes, instead of multiplying these two insides, I divide the two insides. I don't have a log over here to cancel out the log, so my only other option is to do the exponential trick. 5 squared equals x plus 3 over x. 5 squared is 25. All right, now I have to look at this equation and figure out how to solve it. What would I do? I have a fraction. I can always get rid of fractions by multiplying by its denominator. Make sure you do it on both sides. So 25x equals x plus 3. And now this is a lot more obvious to see how to solve it. I need to get the x's by itself, so I'm going to subtract x from both sides. And then divide by 24. And does 1 over 8 work? 1 over 8 here is positive. 1 over 8 plus 3 is still positive, so this is actually the answer. All right, so here's the one for you to try on your own. All right, take a second, pause the video, try this one. I'll show you the answer in 3, 2, 1. All right, you should get an answer similar to this. So plus sign, multiply, no log over here, so we use exponentials. 2 to the 5th is 32. Here we distribute, move the 20 over, and divide. All right, again, check for extraneous roots, but 12 over 5 plus 4 is going to be positive, so it's going to work in that logarithm, and this is good for your final answer. All right, so if you don't have similar things on both sides of the equation, you're going to have to use inverses. If you have an exponential equation, you switch to logs. If you have a log equation, you switch it to exponentials. All right, and just make sure you simplify as much as possible before you switch. You just have to have a single exponential or a single logarithm before you do that switch, because that's the way the original definition works.